Okay, this section is 6.2, deals in Math 830. It's going to deal with some tutorials about permutations. And what a permutation is it's simply an arrangement of things in a specific order. That's what a permutation is. And what the formula is on page 194 of your, or 190, I put 196, but it's 194 of your textbook. And it's n factorial, which means the counting down principle. If you're going 5 factorial, that's 5 times 4 times 3 times 2 times 1, over n minus r factorial, where r is the number of objects that you're going to select from a group of n. So n and r, n always has to be larger or equal to r. And I've got some word examples here, but let's just do the bottom applications first of calculating them. And I will show you how to use the factorial button on your calculator. Okay, so I'm going to do the first one by using the factorial button on my calculator. So this one here, calculate 12 pn. So that means 12 is the n value, and r value is 7. That's how it's written if you look at the formula back up here. So if we calculate that, that would be 12 factorial over 12 minus 7 factorial. So this is equal to 12 factorial over 5 factorial. So you can write it out the long way. You can go 12 times 11 times 10 and keep on going. But it's much, much easier if you just go on your calculator and look for that x explanation point. If you look at my calculator here, it's the, here, let me see if I can focus that here. It's right above my 3 here. So it's just my shift above the 3. It's just an x with an explanation point. Okay, so, sorry about the focus. It's not great on this camera. But anyway, so what we do is we go 12 and hit the factorial button. Or if you don't have that, you just go 12 times 11 times 10 and keep doing that until you get to the end. And that's going to be 479001600 over 5 factorial. So it's a good idea to put that in your memory. 5 factorial is a lot easier to do. It's just 120. 5 times 4 times 3 times 2. And then you just divide the two things together. And you could probably get by just doing that right on your calculator. So I get a total of 3991680, or if we like to put that, 3,991,680 would be that answer. Now let's do the permutation for 11p3. So that would be 11 factorial over 11 minus 3 factorial. So that would be 11 factorial over 7 factorial. So plugging it in. Oops, made a mistake there. 11 factorial. 3991680 divided by 7 factorial. 5040 equals 7,920. Okay, so that's how you just plug them in using your calculator and the factorial button. If you don't have a factorial button, it's considerably longer work. You have to do out the multiplication on your calculator. So let's take a look at some word examples in permutations here. Let me check my field of view. Okay, so how many 5-letter arrangements are there from or for birthday? So birthday here has no repetitions, which is important, but there's 1, 2, 3, 4, 5, 6, 7, 8 possible letters there. And we're going to choose 5 of them. So we're basically going to do 8p5. So that's 8 factorial over 8 minus 5 factorial. So 8 factorial over 3 factorial. So I'll write this one out the long way because it's a shorter one. So this is what it would look like. if you didn't have the permutation button on your calculator. And you can see that it would just be 8 times 7 times 6 times 5 times 4 if you were doing it the long way without the factorial buttons. So we get 6,720. Okay, how many ways could the alphabet be arranged in 15-letter codes? Okay, so we want to do 26 letters, P15, because we want to choose 15 of them. So that would be 26 factorial over 15 factorial. Oops, sorry, 26 minus 15 factorial. What am I doing there? So that would be 26 factorial over, if we minus those two, it's 11 factorial. So let's plug that into our calculator. 26 factorial divided by 11 factorial. So I get a huge number. I'm just going to round. It's 1.0103 times 10 to the 19. So that one, we're just way up in there. Huge, huge number. And that's an example of using the permutation formula. I don't have any more examples, but basically that's a strict use of the permutation formula. Remember that permutation means an arrangement of things in a specific order. And in the next section, we'll be looking specifically at permutations that have repetitions in them.